Hello everybody. Today we start with a new chapter in Chemistry Standard 9th ICSE, that is Periodic Table. It's chapter number 5 from Viraf Dalal textbook. Now, Periodic Table is basically a method by which the people, or you can say the scientist, has tried to uh, group the different elements together so that studying them becomes easier. So initially, if we talk about the uh, periodic table ke pehle, before the periodic table was there, the people always differentiated the substances as metals and non-metals. Okay, ये metal है, ये non-metal है, without even seeing that okay, what is the property of it or how it is going to be there, how it is going to react with the substance, or whether it is highly reactive or less reactive. Okay, so initially it was not being differentiated much, and moreover at that time the number of elements which were discovered were also less, and that's why it was in a way also easier to study those whatever elements which have been discovered. But as and when the number of elements which are discovered got increasing day by day, then the need for something which would ease out the study of the different elements was needed. Moreover, it was also seen that many of the elements had similar kind of properties. So that gave the people more advantage, or more kind of pushing force to tell that nay, there has to be some kind of thing which will make these substances grouped in such a way that if you study one, automatically the ones which are below it or the one which is above it in the table is going to be easily understood. So this is one of the reason why periodic table was formed. So let's start with the introduction. So an element is a basic unit of matter. They are pure substance made up of one kind of atoms and cannot be broken down into simpler substances. So we know very well the atom is of a pure substance, that is, it is made up of only one kind of atom and they cannot be further divided into smaller, simpler substances. There are today about 118 elements discovered so far. Elements are made up of identical atoms. For example, an element iron is made up of only one type of atom, that is iron atoms. Elements have to be properly classified, and the best classification is one which puts together those elements which show maximum resemblance and separates the other. Yes, that's the main reason for periodic table to be generated. They wanted to categorize the elements in such a way, they wanted to group the elements in such a way that when you group them together, the ones which has got the similar kind of the resemblance or in properties are grouped together, and one which are different are separated out easily. So that's the main purpose of having the periodic table. Now, basics of classification of elements. So how did it start? So the start of the classification of elements was based on, first of all, the early chemists' attempts to classify elements on the basis of their properties, nature, character, valency, etc. So we have got, these are the things which are required to be categorized, or these are the one on, or the categories on which a particular element should be ग्रुप टुगेदर. सो वन इज द प्रॉपर्टीज. अगर प्रॉपर्टीज में सेम है तो उनको ग्रुप कर दो, या तो नेचर वाइज दे आर मेटल्स, नॉन मेटल्स, रिएक्टिव मेटल्स, नॉट टू रिएक्टिव, तो वो जो है उसके हिसाब से द नेचर वाइज वेदर इज हाईली रिएक्टिव और सच टाइम्स. Similarly, the next one is characteristics wise. So whether ionization potential, जो हम लोग characters we are going to study those characters mainly in the 10th standard. So each and every element has got certain characters to attract the electrons towards itself, or to remove the electrons from something. So these are some characters which are talking about. And valency, of course, we know that the number of electrons required to complete its outer orbit to be either given away or taken or sharing. So the first kind of the classification which came up was the Daubenius Triads. So it was Daubenius. Okay, it is Daubenius Triads. So he arranged elements in increasing order of the atomic weight in the group of threes called triads. Okay, I'm just going to read them because they have got a detailed thing later on in the chapter. So I'll just go through it right now in a superficial manner. Newland in 1864 arranged elements in increasing order of the atomic weights and suggested that in this given series, every eighth element has a repetition of the first. So he said that, so first was a triad. Triad means 3 के groups बनाए थे उसने. So 3 will be there, they will be having similar characteristics. And the next one was Newland. Newland said that if I'm arranging the elements in the increasing order of the atomic weights, then the first one and the eighth one will have a similar characteristics. Okay. Second का eighth के साथ, third का ninth के साथ, ऐसे करके the first and the eighth characters will be, eighth element will be similar, second and the ninth will be similar, third and the 10th will be similar, वैसे करके. He gave this Newland's octet. Next is Mendeleev. Mendeleev arranged the elements in increasing order of the atomic weights in the form of a table called periodic table and observed that elements with similar properties appear at regular intervals. This is called the periodicity of the periodicity of the properties of the elements. He stated that properties of the elements are periodic functions of their atomic weight. So Mendeleev said that the properties of the elements are periodic functions of the atomic weights. So if I'm arranging increasing order of the atomic weights, then at a particular intervals there will be similar kind of elements available, and hence we formed a table which was the first periodic table. Moseley in 1912 arranged elements in increasing order of the atomic numbers and found that atomic number is more fundamental characteristics of element than its atomic weight. And he stated that properties of the elements are the periodic functions of their atomic number. So Moseley changed the Mendeleev's periodic table from atomic mass to atomic number. So he said that it is the atomic number which is much more important for an atom rather than the atomic mass. And of course it is quite true why this would have happened, because Mendeleev did it in 1869, and you remember that in 1869 there was no differentiation between the atom as protons, electrons and neutrons. The protons at that time, nobody knew that there were protons, electrons and neutrons, and hence atomic mass was the only consideration of the atom. Atom was indivisible because at that time everybody believed about the Dalton's atomic theory that atom was indivisible. So they did not know that how the atoms are reacting with each other and the electrons and the protons. So that's why only after the discovery of the electrons and protons it came into existence that okay, हाँ electrons है, valency है, ये electronic configuration है, and hence the atomic number came into picture, and it was atomic number which brought about the drastic change in the way we see the periodic table. So that was done by Moseley in 1912. So let's see one by one how these people have worked about it and what are the difficulties, or we can say the limitations of the things what they have done. So we'll be in each and every case that we are going to see Daubenius Triads, and then we're going to see the Newland's octave, and then Mendeleev's periodic table, and then the Moseley's periodic table. In each and every case we will be studying what was their periodicity based on. We will also see what were the disadvantages, or you can say the limitations of that particular thing and why it failed. So the drawbacks and why that particular thing failed, or what are the drawbacks, is what we are going to learn in each and every part. So first thing is Daubenius Triads. So first of all, okay, before that, early chemist. Classification by early chemist. Basis of classification of elements. on basis of property, valency and metallic and non-metallic nature of the elements. The above method of classification was discarded since metal elements behave both as metals and non-metals, show metallic and non-metallic nature and have variable valency. So initially it was just what they wanted to make it very simple, and by that they wanted metals, non-metals. So we have got the properties wise, so either it is metallic or non-metallic, or it has got a variable valency. But then we came to know that there are many substances which are going to act in a metallic form or in the non-metallic form, or like metalloids or could also be there, and so it could not be the exact way we are able to identify, or we are able to judge the particular element. So that's why it was not the right method. And then came the atomic weight and not property. Atomic weight and not properties were considered for further classification. So then what came up was that okay, it should be the atomic weight should be considered for the classification of elements and not the properties. So when atomic weight was the first criteria, so the thing what was done by Daubenius was that he took three elements of similar characteristics, and then he's found that the atomic weight, so he took, suppose we take A, B and C, suppose the atomic weight of this is 10 and this is 30, you will find that the mean of these two is 20, 30 plus 10 is 40, 40 upon 2 is 20, so this 20, they will find that if these three are of similar nature, then the atomic mass of the second one is the arithmetic mean of the first and the third. So that is exactly what Daubenius gave it as triads. So he made triads of three elements, and these triads were such that they had got similar properties, and also that the atomic masses of the first and the third of the second was the arithmetic mean of the second. So Daubenius arranged the elements in increasing order of atomic weight in group of three called triads. Daubenius law of triads was chemically analogous elements. Chemically analogous means similar. Okay, chemically analogous was similar reactivity, the one which has got similar kind of characteristics. So chemically analog elements arranged in increasing order of the atomic weight formed well-marked group of three called triads, in which the atomic weight of the middle element was found to be generally the average, that is the arithmetic mean of the atomic weight of the other two elements. So that's what he said, that the atomic weight of the middle element was found to be the arithmetic mean of the arithmetic mean, that is the average of the other two elements. So the example they are given over here is, this is lithium, and then he took sodium and he took potassium. So lithium, he knew that this is 7 and this is 39. We know 39 plus 7 is 46, so this is 23. And yes, it is correct that sodium has got the atomic weight as 23. So the atomic weight of sodium is the average mean of lithium and potassium. So this was absolutely true, but this did not function well because the method was a disordered collection of elements, not holding true for all elements. So this was not true for all elements. Even if some three elements we take which are in the arithmetic mean of each other, then it was found that they are not chemically analogous, or if we find that they are chemically analogous but still they will not be the mean. So it was not exactly the way he wanted to portray. Only certain groups which were formed were in this particular thing were obeying this particular kind of method. So that's why the properties of elements grouped in triads were found not to be similar. So either thing was there, either the properties which were of the group which was formed was not similar, or if it is similar, it was found that they were not in the forming a triad. So easily you can see that the Daubenius triads failed. The next is Newland's law of actives. Basis of classification elements, Newland arranged elements in increasing order of the atomic weight in series of 8. So what he did was, Newland was the next person who came up with some new idea, and he gave, which is called as Newland's octave. Now Newland So Newland found that most of the things in the earth are in a group of seven oceans, seven continents, seven colors of the rainbow, the seven notes of the musical sound, like do re mi fa sol la ti do ya sa re ga ma pa da ni sa. So sa re ga ma pa da ni is the seven and sa is again repeating. So similar, he said that जैसे म्यूजिकल नोट में सारे गामा पदा नी सा है, तो दैट सा एंड दिस सा आर सिमिलर. Similarly, in case of the elements also, if we are arranging the elements in the increasing order of their atomic weights, then the first one and the eighth one will be similar to each other. Similarly, the second and the ninth one will be similar, third and the 10th will be similar. So accordingly, you will see that if you arrange them all together, then 7 days in a week के हिसाब से भी जैसे वही तो कैलेंडर में जैसे हम लोग देखें तो 1, 8, 15 आता तो वैसे ही the one with the atomic number 1, other atomic number 8 and atomic number 15, तो वो जो है they are the one which are going to have similar characteristics. Okay, not that they are always in 1, 2, 3, 4 form, but yeah, but the 8th element and the 15th element, they will first 8th and 15th element will have similar characteristics. So basis of the classification elements, so Newland arranged elements in increasing order of atomic weights in series of 8. Newland's law of octave: elements when arranged in increasing order of the atomic weight show resemblance in physical and chemical properties between the 8th element and the first element, similar to the 8th element and the first note of the musical scale. So similar to the musical scale, sa, re, sa or sa, the two sa's, which is 1 and the 8th one. Similarly over here also, the first and the 8th one will be similar. The 8th element lithium and is the 8th element from lithium is potassium, and from fluorine it is chlorine, which show similarity in properties. So yes, if you see the structure, yes, you can see that lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. At that time, the neon and argon and the inert gases were not being discovered. So we are talking about this thing in the year 1864, wherein there was no discovery of the inert or the noble gases, and that's why the elements of like argon, neon, krypton was सब था ही नहीं उसमें. Okay, तभी वो सब they were not existing. I mean, it's not existing, meaning not discovered. Sorry. So it is seen that the method showed odd grouping and failed to leave spaces for undiscovered elements. So the main problem or the drawback with the Newland octet was that there were certain areas wherein when you group them together, they were not having similar properties. And another thing was that once any new substance was discovered, it did not have place for it in between. So it is possible that something would have been similar. So like for example, 15th was discovered, 18th was discovered, and there is something in 16 over here, but we don't know that 16 was existing or not. So you never kept a place for that. And then you find that a new substance has been discovered which is having an atomic mass as 16, which is to be placed between 15 and 18. तो उसके लिए जगह ही नहीं है. So automatically the problem phase was that it did not. So first thing was that it showed odd grouping and failed to leave space for undiscovered elements. Method of classification showed meaning with light metals, that is lithium to potassium. Yeah, till light, but light elements जहाँ तक था, जब तक atomic weight was not too high, till 40 तक, तो atomic weight 40, it was not a problem. But the moment the weight, that is atomic weight, was higher and but failed with heavier metals beyond potassium, that is beyond K, that is 39. So you can see that this particular kind of a method, that is Newland octave, failed for reasons. First thing, it was grouping odd items together. Secondly, there was no place for the undiscovered elements. And thirdly is that it showed good similarity for lower, or that is the lesser weight atomic weights, which was less, वहाँ पे उसका अच्छा परफॉर्मेंस आया. बट the moment we are talking about any element which was higher in the mass, that is atomic mass, that is beyond potassium, that is beyond 39 AMU, they failed to give the proper results. So that was about Newland's octave. The next one was given by Mendeleev, and that is Mendeleev periodic table. So the next one is Mendeleev. So first of all, this is the first periodic table. Up till now it was just some kind of a tabulation वगैरह, but यहाँ पे एक proper table बनाने की try किया. Okay, though there it has got, the table is the one which has got a proper groups and columns. Okay, so it has got columns which are horizontal, vertical columns, and horizontal rows which are the groups. So groups and columns were the first time it was having the periodic table was being formed with groups and columns. So basis of classification of elements was Mendeleev arranged elements in increasing order of atomic weights in the form of table under the and called the periodic table. This arrangement had elements with similar properties appearing at regular intervals. This phenomena is called as the periodicity of the properties, and the properties which repeated themselves at regular intervals are called as periodic properties. Periodic properties include atomic radius, ionization potential, electron affinity, etc. So that's what he said, that Mendeleev arranged everything in form of a tabulation, a table, and he arranged them in a particular form that all the similar elements was grouped in one particular column, and each and every column will have different characteristics of elements. So accordingly, each and every group will be having different characteristics, and there will be a repetition of the properties of the elements at periodic intervals, and that particular thing he called it as periodicity of the periodic table, or you can say the periodic properties are the that's what he considered it as the periodic properties. The periodicity of the are the properties which repeat themselves at regular intervals in the periodic table. And the periodic properties are atomic radius, so the size of the atom, the atomic radius, ionization potential, that we will discuss later in the 10th standard. Ionization potential actually is the energy required to remove an electron from an atom. So कोई भी atom का में से electrons अगर remove करना है for valency point of view, then it is put initial in electron ionization potential. Electron affinity is to attract the electrons towards it, so to accept an electron affinity is there, and there are any other properties. So that is the periodic properties. Now, so Bentley Periodic Law, so he made a law, and that says that the physical and chemical properties of elements are periodic functions of their atomic weight. So the atomic weight is going to determine the periodicity, or we can say the properties of the elements are dependent on the atomic weights. So depending on the what is the atomic weight, it will also tell you that what is the property of that particular element. So he grouped them in series, that it was group 1, 2, 3, 4, 5, 6, 7, and he made the columns 1, 2, 3, 4 ऐसे करके columns बना दिए, rows बना दिए. So columns where there were 7 columns and there were rows. Now Mendeleev's original periodic table, first 3 periods are shown over here. So now the main thing over here is this made a very clear picture of grouping. By grouping it, he made a very clear picture, and moreover, it also did some remarkable thing about leaving spaces of the undiscovered elements. Also, he tried to cross-check and found out that many of the calculations for the atomic weights which was done earlier were wrong, and he automatically changed those also. How did he change it? Because he knew that अच्छा ये इधर है और ये इधर है, पर इसका पोजीशन तो यहाँ पे होना चाहिए, because इसके साथ में इसका see, it is this way. he told that ये group के अंदर the properties 1, 2, 3 and 4 जो है, they should have similar properties. Now if he finds that this 2 actually is placed in G2 over here, तो उसको मालूम है कि यहाँ पे कुछ problem है, तो there should be something, यानी इसका atomic weight should be here and not here. तो एटॉमिक वेट को इसलिए उसने क्रॉस चेक किया और फाइंड किया whether it is true or not, and then he came to know that नहीं, now this इसीलिए 2 will not come here but 2 will come here. So that's what he said. Mendeleev's contribution is elements were arranged in increasing order of the atomic weights in horizontal rows called periods and vertical columns called groups. So he made the table with the horizontal rows as the periods and the vertical columns as the groups. Elements which are similar with respect to their chemical properties are grouped together and have atomic weights of nearly the same value. So first thing is that elements having a similar with respect to the chemical properties, if they are similar, then they are grouped together and have atomic weight of nearly same value. Elements of in the same group, so if they are in the same group, had same valency and similar chemical properties. So the chemical properties of these ones were similar. In the group में जो है उसके chemical properties were similar because also they had got similar valency. Based on the periodicity of the properties, a number of gaps were left in the table for undiscovered elements. So because he knew, like for example, suppose यहाँ पे हम लोग लेते हैं कि यहाँ पे कुछ नहीं था. Let's consider that this is atomic masses मैं लेता हूँ, just 3 के लिए लेता हूँ. Suppose this is like 11 and this is like 14 and this is like 17 and suppose यहाँ पे नीचे है that is like 23 and this is not known, but here you know that this is 27. But you know that if I put 27 over here, then these two are not having similar properties. But 27 if I put it over here, then these are matching. इसी उसने क्या किया? He gave this as a gap. He kept it as a gap, saying that there should be some another element which can be discovered later on, which will have properties similar to this. So he left empty spaces in his periodic table, which were meant for undiscovered elements. And in fact, he also determined कि एज्यूम किया कि अगर वो रहेगा तो भी उसका प्रॉपर्टी ऐसा रहेगा और उसका वेट अप्रोक्सीमेटली इतना रहेगा. So he could even foresee or he could predict certain kind of elements over here which would have been present, which were at that time undiscovered. So based on the periodicity of property, a number of gaps were left in the table for undiscovered elements now discovered as scandium, gallium and germanium, originally called as Eka boron, Eka aluminum and Eka silicon respectively. So what he did was that he knew that this, suppose over here he knew that this is aluminium, तो उस या बोरॉन है, तो ये बोरॉन है, तो उसने क्या किया, इसको एका बोरॉन किया. He named it Eka boron because it had properties similar to the boron. Okay, but it was undiscovered, which was finally he came to know that it is nothing but scandium. वैसे ही Eka aluminum, which is gallium, and Eka silicon, which is germanium. The properties of undiscovered elements left in the vacant space was predicted. He predicted that okay, यहाँ पे एक particular आएगा element जो हम लोग बाद में discover करेंगे, पर उसके properties will be something like this. And also incorrect atomic weights of some of the arranged elements were corrected with the knowledge of atomic weight of the adjacent elements. So with the knowledge of the adjacent elements के हिसाब से many of the atomic weights were corrected, and this were the main contributions of Mendeleev's periodic table. But still, it did not work. So why did not work? What are the drawbacks? What are the defects? The first thing is, anomalous pairs of elements, certain pairs of elements having higher atomic weight have been given position before the elements having lower atomic weight. So in certain places, he had given the atomic weight of a higher one before. Like उसने क्या किया था? Like suppose यहाँ पे होना चाहिए 29 और यहाँ पे 30 होना चाहिए. He purposely made this as 30 and this as 29. Why? Because he knew that these are similar and these are similar, but he was not able to explain why he did so. So that's an example over here. This defect is when he arranged the atomic number. Okay, so atomic weight of cobalt is 58. See, it is cobalt is 58.9, and that of the nickel is given as 58.6. So according what should have happened, this would have come first and this would have come later. So it was like this, that the CO should have been here and NI should have been here. उसने क्या किया? He put the NI here and CO here. And when the people asked him why did he do that, he had no answer for it, because he just knew that yes, this was similar to nickel and this was similar to cobalt, but of course there is no reason why he had put that particular changes, which automatically got sorted out. The problem got sorted out when the periodicity was not dependent on the atomic weight but was taken in atomic number, because now atomic number lete hi kya ho gaya, this one over here, the cobalt over here is 27 and this over here is 28. So automatically what has happened, now the cobalt is over here 27 and nickel is over here. So jo usne change, one sec, I think, okay, I took it ulta earlier. So this is, you can see this is greater and this is smaller. So actually क्या होना चाहिए था, this should, the nickel should have been here and cobalt should be here, right? I wrote it ulta earlier. So nickel should be here and cobalt should be here. Instead of that, he put cobalt over here. So in the periodic table, he put over here cobalt and nickel here like this. But when the people asked him, this is 58.9 and this is 58.6, then this should have come here. And this should have gone here, but no, he said no, it will come this way only. But there was no reason for it. But now when we know that it is based on the periodic atomic number, you know that this is 27, this is 28, so automatically cobalt will come first and nickel will go next. The position of rare earth and actinides could be justified only if arranged according to their atomic number. So there was no position for the rare earth and the actinides which are there in the modern periodic table, and also position for isotopes ka problem ho raha tha, because isotopes, you know, it's of the same element but different atomic numbers. So hydrogen ki 3 isotopes hai, 1, 2 and 3. Hydrogen 1, hydrogen 2 and hydrogen 3. Where will I put in the periodic table hydrogen 1, 2 and 3? So that's why isotopes had never been, so isotope had to be placed in the same position according to the atomic number, because we did not have any particular reason for that thing. Hydrogen ही है, तीनों दिन hydrogen है, तो उसके masses अलग अलग है. So that's why position of isotope was a problem. So these were the importance as well as the drawbacks of the Mendeleev periodic table, right? And now we move on to the modern periodic table, which is also initially called as a Moseley's classification. Okay, but we will do it in the next video.